Alright, good morning everyone. Today we are continuing on with our programming tutorials. We are going to take a look at our STM32 based MicroDev boards today. Mainly the STM32L072 and also the STM32F411. We are going to take a look at how to program these development boards through the Arduino. Okay, now let's set up the Arduino IDE for our MicroDev STM32 boards. All of our datasheets contain a programming guide, and it's basically this programming guide that we're going to follow today in this video. Right, so first off, we need to download the board package for the STM32 microprocessors. We'll go into the Arduino IDE and we'll press Board Manager. We'll search here for STM32, and the board package that you want to use is this one, currently at 2.11. This one is issued by STM themselves. And if you don't see this board package here when you search for STM32, you might have to go into File, Preferences, and in additional board manager URLs, you would have to copy in this link right here. This link will of course be in the description of this video as well. Now this link actually takes you over to the GitHub repository. And in the GitHub repository, there is also a getting started guide here for the STM32 microprocessors. And if we click this one, we can see here that there is actually an additional step at the end that we need to complete, and that is to download STM32 Cube Programmer. The STM32 Cube Programmer is a software that allows you to flash their MCUs with their own debugger, the ST-Link debugger. However, the board package uses some of the commands included in this software, so we need to download this. And once you've downloaded this and you've downloaded and installed the STM32 MCU board package here, you are ready to program your MicroDev STM32 device. Okay, so we are complete with the initial setup now. We can move over to the actual setup for our particular board. In this case, we are going to use the STM32L072, but the process is identical for our STM32F411. And if we jump over to the datasheet for the F411, and again go down to the programming guide, we'll see the steps are identical. However, here when you do the actual setup for this board, you'll have to select these parameters instead. Mainly, you'll have to select that you want to program a generic STM32F4 series microcontroller. In any case, let's jump over to the Arduino IDE and make sure that we have all of these settings correct. We'll go into Tools, and we'll need to select the board. It's going to be an STM-based board, and it's going to be a generic STM32L0 series microcontroller. For the debug and core logs, we'll go for none. We'll optimize for smallest Q. And here we'll actually have to select the proper part number. And again, in our datasheet here, we can see that the proper part number here is L072CBT. So let's check that. We'll go in here and we'll scroll all the way down to the L072 variants, find the L072CBT over here. Good. Now, next up, we are going to use this new libnano default library. After that, we are going to select DFU mode for our programming. And here you can see that we are utilizing the STM32 Cube Programmer here. You could also program it through CRY debug. However, then you need a ST-Link device in between. We'll move on with USB support. We'll go with a generic serial, and this one supersedes UART. This will allow us to send the data to the COM port here in Arduino IDE. And we'll also enable generic serial here for the UART. Alright, we are now ready to start upload our code. Let's have a quick look at the code before we upload it. This time the code is actually a bit more advanced than what we've seen previously. We've actually included the HUL library here. The HUL library is basically STM's own API, which allows you to access quite a lot of fancy functions within the STM32 processor. What we're going to do here is we're actually going to read the internal temperature sensor of the microcontroller. We'll do this by accessing some calibration data that's stored already on the microcontroller. And then we'll set up our ADC here. We'll set up the ADC to actually read the internal temperature sensor. We are also reading our, let's see here, we're reading our reference voltage and actual VDD value, which we're going to use in the calculations. But as I said, we're not diving into the code in this video. So we're setting up the ADC. All of this is basically setting up the ADC. We scroll further down to our main loop. We fetch a few ADC values. We print out some VRF values and some temp values. We print out the raw temp value, and then we calculate our actual VDD voltage. We use this actual VDD voltage later on here in order to calculate the actual temperature from the temperature sensor. And we are, of course, toggling our LED. You can't have a program running on a microcontroller without toggling the LED. Alright, now let's plug in our MicroDev board. And we'll go into Arduino IDE and see if we can find the COM port. You can see here on COM port 6 we found a 3D printer, a Discovery, a electric board. Sometimes these will show up as these generic devices. Alright, now we'll have to put the MicroDev into boot mode. For the STM boards, you simply press and hold down the reset button, and you press and hold down the boot button. Then you release the reset button, and now the MicroDev is going to be in boot mode. We can then double check that we have a COM port, but as you can see now we don't have one. And in our datasheet this is actually covered, and sometimes when you first plug in these STM32 boards they will not show up. However, once you upload code to it, it will show up. So we can simply press the upload button, and we'll compile the sketch and wait for a little bit. Alright, there we go. Okay, we have successfully uploaded our code. We can now go back to the COM port and see that the COM port has shown up again. We'll open up our serial monitor, and here we can see we are spitting out a bunch of values. Here are these calibration values that we talked about. But what we're interested in today is this internal temperature sensor right here. And we can see now it's telling us that it's about 19 degrees Celsius here in my cold room. But what if we place our finger on top of the MCU? We should see the temperature increase, hopefully. My body temperature is a little bit over 19 degrees. And yes, indeed, we are climbing. 21, 23 degrees, 25 degrees C. And there we go. That's the programming guide for our MicroDev STM32 boards.